Good afternoon, Senior 2 students. We're still in Chapter 1, Lesson 4, Principles of Distributing Electrons. In the previous session, we have explained the 4 quantum numbers that help us to know the place of high probability to find an electron. And here, we are gonna know how can we distribute the electrons in the orbitals. There are some important rules that must be considered in distributing the electrons. These rules are: number 1, Pauli exclusion principle; number 2, off-bow or building up principle; and number 3, Hans rule. Let's start with the first one, which is Pauli exclusion principle. This principle states that no two electrons in an atom have the same 4 quantum numbers. It is impossible to find 2 electrons in the same atom having the same 4 quantum numbers. And to understand this more, let's take an example. We have here helium in its ground state. Its electronic configuration: 1 is the number of principal energy level, and S sublevel contains 2 electrons. We have here in the orbital 2 electrons. Let's know the 4 quantum numbers of these 2 electrons. For the first electron, principal quantum number is 1, subsidiary quantum number is 0 because we are in S sublevel. Magnetic quantum number will be also 0. In the second electron, the blue one, principal quantum number will be also 1, subsidiary quantum number 0, and the magnetic quantum number is 0. These 3 quantum numbers that describe 1s orbital are the same in both electrons. Where is the difference here? The difference is in the spin quantum number. We have here 2 electrons that spin in 2 opposite directions. So the first one denoted by positive half and the second one negative half. So they have the first 3 quantum numbers equal, but they are different in the 4th quantum number, which is spin quantum number. Let's move to the second principle, off-bow principle or building up principle. And this principle states that electrons are added to the lowest energy orbitals first. Then, after filling the lowest energy orbitals, we start to fill the higher energy orbitals. Let's take an example. We have here lithium atom that has 3 electrons. So we start from the lowest energy sublevel. We have here the principal quantum number is 1, and we are in S sublevel, and S contain only 1 orbital, and we have known that each orbital is filled only with 2 electrons. So we fill 1s, then the remaining electron is going to fill 2s sublevel. So we start from the lower energy level orbital. After filling the lower energy orbital, we can move to the higher energy one. We have another way in electronic configuration. This way, by putting here the number of principal quantum number, which is 1, we are in first energy level, and putting here the symbol of sublevel, and this sublevel occupied or filled with 2 electrons, we can write them in this form. The second energy level, n equal 2, and we have here it contain sublevel S, and the remaining electron is put here. How can we know which one or which sublevel has lower energy? By applying a sample relation, adding the principal quantum number of a given sublevel plus its subsidiary quantum number. For example, we want to know which one has higher energy, 4s sublevel or 3d. Let's take this relation and apply it to this example. 4s, its principal quantum number equal 4, and the subsidiary quantum number of S sublevel is 0, so 4 plus 0 equal 4. The second one, 3d, the principal quantum number here, 3, and the subsidiary quantum number for D sublevel is 2. 3 plus 2 will be 5. From applying this relation, we have known that 4s has lower energy than 3d, and we can distribute the electron from the lower energy levels to the higher energy levels or sublevels by this way. In order, first we fill 1s, then 2s, 2p, 3s, and so on. Let's take another example on the electronic configuration. We have here the ground state hydrogen atom that contains 1 electron. So we have to put only 1 electron in the first energy level. The first electron must be put having the spin quantum number positive half, or its spinning will be clockwise with the clock direction. Or in another way, we have here 1, the number of principal quantum number, s is the sublevel s, which is filled with 1 electron. So we have 2 ways in the electronic distribution. Another example, we have here beryllium has 4 electrons. We start with the lower energy sublevel 1s, and we are gonna fill it. Then we have to move to the 2s sublevel. Or we can write it in another way, 1s2, 2s2. Another example, boron has a total of 5 electrons. Let's start 1s, 2s, and the left electron we can put it in 2p sublevel. Let's move to the last rule in our lesson, which is Hund's rule. This rule states that no electron pairing takes place in a given sublevel. Not put the electrons in double form, 2 electrons, until each orbital contain 1 electron. Let's take an example to understand this rule. We have here 1s filled with 2 electrons, 2s filled with 2 electrons, then we are moving to p sublevel. We cannot put here 1 up and 1 down. We cannot make electron pairing until we make sure that all p orbitals have at least 1 electron in the same spin or in the same direction. Again, electron pairing means we put 2 electrons in the same orbital. We cannot put 2 electrons in the same orbital until we make sure that all the orbitals of this sublevel contain 1 electron. And here is the electronic configuration of carbon atom. Another example, we have here nitrogen, which has 7 electrons. Let's start the electronic configuration. 1s, 2s, and we have 3 electrons left, so we put them in single form. Each p orbital contain only 1 electron. And why we do that? Why we don't pair the electrons first? Because if we put 2 electrons have the opposite spinning, they will suffer from a repulsion force. So it is more stable, or for the stability of the atom, we have to put them first in single form. Then another example, we have here oxygen has total number of electrons 8, 1s, 2s, and we have here 4 electrons left. So we put it single electron, single, single, then the left one we are gonna pair from the first orbital, 2px. And here is the other way in electronic configuration. Another example, we have here fluorine that has 9 electrons, and let's see the electronic configuration of it. 1s, 2s, and we have 5 electrons left. So we put them single, 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 then the left 2 electrons are gonna do pairing after that. Here is the second way of electronic configuration. The last example, we have here neon that has total number of electrons 10, Let's start the electronic distribution. 1s, 2s, and 2p is completely filled with electrons. You can observe that p sublevel has 3 orbitals and each one is completely filled with 2 electrons. Final summary of the lesson. Number 1, electrons prefer to be in the lowest available orbital, the orbital of the lowest energy. Number 2, each orbital can be only filled with 2 electrons. Number 3, if we have a sublevel contain more than 1 orbital, no electron pairing will take place until each orbital in this sublevel contain 1 electron. The last point, orbital will fill in order as shown in figure. 1s, 2s, 2p, 3s, 4. Thanks for listening, Senior 2.